Hello there, welcome to the wonderful world of radio frequency and electronics engineering. Hope you're doing well. On the bench today we've got a wonderful piece of equipment to have a look at here. Quite an old school piece of equipment that's really good. Well sought after, these ATU antenna tuning units. This particular one's been given to me for test, just to make sure it works and everything functions on it. And we'll just have a quick run through it and give it a live on air test as well, using the HF antenna that we've got here for real live tuning in. So yeah, this piece of equipment allows us to tune antennas in, whether long wire, verticals, all sorts of different types of antennas, between 1 MHz and 30 MHz. It has a handling power of up to 150 watts CW. And it's got an integral dummy load in it, so when we press that button there, it's got an internal RF load so that you can terminate the RF power internally within the unit. We have a through button as well, a button that basically bypasses the ATU altogether, so the coaxial RF relay switches the RF into the antenna RF out. We've obviously got the power button. The power on this unit is 12 volts DC, the same as what you will get with the radio, 13.8 volts. And then with two buttons here, both have dual functions. The first button is the SWR. When it's in, it reads SWR, and out it reads power output up to 150 watts. And the second button here, again dual function, allows the scale to read either 15 watts maximum power or 150 watts. We've got a sensitivity control which allows us to better tune into weaker QRP signals that come from low power transceivers, particularly those that are less than 5 watts, so that it allows the ATU to pick up, particularly when using it on SSB, periods of RF that are just in between some of the peaks of the speech, where there's just more or less noise that the microphone picks up in between the syllables. There's slight bits of RF power there, and it allows a better sensitivity of that control to tune in, keep the ATU going, try and find the best spot while you're modulating with SSB signals. Obviously with AM and CW and FM signals, we tend to find there's a carrier wave there all the time, so that it can tune in with those as well. But on SSB, it's particularly useful as a sensitivity control. We've got different antenna characteristics that we can connect to in feeder terminology. Antenna A we're currently on at the moment with an external HF antenna we've got here, connected to antenna A, but we've also got antenna B, antenna B2, 3, 4, etc. You can connect different antenna types, be it ladder line, 50 ohm coaxial cable on SO239, PL259 socket at the back, and you can memorize different tuning positions for each antenna type. So you can have log periodic, long wire, ladder line, coaxial fed. You can have different feeder types as well, all connected to the back of this unit. Then we've got a tune up and down control for manual tuning, as well as a load control, again up and down. We've got a start button which allows us to start the process of the automatic tuning. We've got a manual and automatic selection for banding as well. So all this is fully flexible for automatic as well as manual intervention. And then we've got indicators here right the way up for all the different bands, from 1 MHz right up to 29 MHz up to 30. And then we've got a ready light, so when it's tuned in, the ready light's on. When we actually press the start button while we're transmitting, while the antenna's being tuned in, you keep the transmitter keyed, and the wait light illuminates while it does its thing, and you'll hear motors turning inside and relays clicking, and ultimately it will then select the right antenna VSWR, the minimum possible at that band, given the antenna that you're working, and then the amber light will go back to ready. Obviously this here is the antenna selection, confirmation LED, so we're on antenna A. If the antenna can't be tuned in and the VSWR is excessively high, for whatever reason, the red warning light will appear. So yeah, that's basically a little rundown of that. Right, let's do some testing then. So I've got the radio on 7 meg amateur band. We've selected the 7 meg band on there. When I key up, if a VSWR is into the red, it'll automatically tune it in. So let's hit the transmit button. As you can see, tuning that in. It'll shortly go to green. That's it. So we're tuned in. So obviously, as we can see there, it's tuned in the 7 meg band. Now if I go to the 10 meg band next, let's check that. I've got the 10 meg band selected on both the radio now and on there, and then I'm going to keep the microphone, as you can see straight away. Just tuning that in nicely. That's the 10 meg. Obviously on power, we've got forward power and hardly anything reflected, which is pretty good. Right, so now we've moved on to 14 megahertz and we've got the radio set up on 14 megahertz as well. So let's see what happens. Straight away, got into ATU mode and found the optimum VSWR. There we go. Let's look at our power. Plenty of power there, look, on key. So that's pretty good. Now obviously when we return back to these bands that we've previously been in, every time I go back, now we're on the 10 meg. If I alter the radio to 10 megahertz, what will happen is the ATU has memorised the previous tuning position. Now providing the radio frequency hasn't changed too much, if it does change then we can press the start button to retune, but it'll remember, as you've seen there. Same with the 7 megahertz band as well. When we go to there, it's memorised the position where we were. Now what happens is obviously it's tuning it in if we've changed any of the frequencies. There we are. Now obviously if you tune off let's control, if you tune off, say go on to a totally different frequency and then key up, you can press the start button to get the optimum VSWR like that. And so we've still got the microphone keyed while it's doing its thing. So as we change frequency, albeit slightly from the original, because the VSWR is starting to climb, then you can press start. Now whenever it's under the red zone on the meter, it won't auto tune unless you press the start button. It's only when it gets up to a higher level of VSWR that it'll then auto tune to keep everything in abeyance. So that's how it's designed to work. So what we'll do, we'll go up to the 18 megahertz band, which is there. We'll just select the 18 megahertz band here, and then we'll key up this one, and there we are, look. And tune that in nicely. That's the best VSWR it can get. You can if you want, try the manual tune yourself, you know, then it'll if it's not in auto mode, it'll try and bring the VSWR in automatically for you. And likewise as well, go up to the next band up, which is the 21 meg band. You see it's tuning that in nicely. Just takes a few moments. That does it. Next one. 24 meg band. Again, whizzed into action very quickly. Choosing the best VSWR, and then of course the got a 29 meg band. Here we go again. Very low VSWR and come back into the power going out. So that gives you just a little overview of a tuning capability. Obviously there's lower frequencies as well that you can test. I've done it on as many as I can that my antenna's sort of capable of doing. So, but yeah, so we'll have a look round it now and see what connections it's got. Okay, so on the rear panel, before we have a look inside, we've got a connector on the back here, which is for remote. We've got 2 antenna sockets, A and B. We've got an accessory connectors here for YAESU accessories. We've got a ground terminal as well. We've got the DC input jack, and this here is the input from the transceiver. As you can see, very good condition throughout, been well looked after. So we remove the screws from the lid, and we'll have a look inside. So just put the lid carefully to one side. So very nicely engineered. As you can see here, sort of worked out that this is the 50 ohm termination using big power resistors. This is directly in line with that vent at the top as well as the bottom, so it can get airflow through it, although there's no fan or anything inside. As you can see, there's some very nice gears up here, motors driving these shafts, flexi shafts that turn these vane capacitors. And see if I can put a bit more light on there. That's better. Then we've got different antenna relays and things here for selecting different aerials or feed through, like we were talking about earlier, when you press the button on the front, basically to connect the antenna socket to the transceiver input, these relays that switch in. We've got various inductors as well. We've got a few stepper motors just under there that you can see, and ultimately a motor there for driving different things. We've got a switch, a rotary switch here with capacitors in it, which is on this brass gear here, and then each motor separately for turning these large capacitors. And yeah, pretty well constructed, as you can see. YAESU stuff's always good, always manufacture things to high standard. Nicely put together. Looks like the processor IC this is battery backed up by that little battery there, and then you've obviously got adjustment pots for the different bands and things in order to calibrate the SWR. There's a little switch there, that might have something to do with resetting the processor's memory settings maybe, or something like that. Might be worth having a look at a service manual at some point to see what that's like. So we'll take the bottom off now, and we'll just make sure there's no burnouts or anything like that. That's the reason why we remove the covers, to check for anything inside. You don't know what anybody's done, but so far everything's looking good. It looks like as if this has been well looked after, not been tampered with. So we'll just take the lid off now and have a look there. Right, we'll just take the bottom cover off. I think that's the last screw. There's about 5 screws in each case. As you can see, the feet are all still here, and there's a retractable stand as well, so that's pretty good. Right, just have a look at that. So just the PCB underneath, the motors themselves, some DC motors there, and PCB looks all intact. All the soldering around the SO239 sockets all looks in good condition as well, and there don't seem to be any melting, burnouts, fizz bang, anything like that that appears to have happened, so that's pretty good. Yeah, everything looks good, so I think we'll put it back together and have another look round it once we've got it back together, its physical condition, and move on to the next item. Okay, now we've got it all back together again. The chap who's given it me to test for him has said, can I apply some anti-tamper seals to the unit? So I've done it on both sides here. These are particularly very good foil labels that go checkerboard if you try and pulling them off, and they'll also crack straight across the middle the moment you try and take the case off. So very, very hard to remove or to tamper with. And as I say, we've got one on this side as well, so he wanted that. Got one on the back, obviously serial number label there, and then we've obviously got these. So very, very good, nice little unit. So obviously if he wants to sell that now, at least he's confident that the you know, the ATU works fine on all its bands and tunes in properly as it should do. We've looked inside to check there's no modifications being done or burnouts or any problems like that, and there hasn't been any issues around that. So yeah, I think we can send that back to him in confidence, for knowing full well that if he wants to sell it, it's guaranteed working, and no problem there. Okay, so let's have a look at the ICOM707 radio transceiver. Today we're going to use the CMS33 radio test set made by Rohde Schwarz, and today's measurements, we're going to measure in peak envelope power, so we'll get the peak of a transmission. Now this radio supports modes AM. If it had the option board fitted, it would be FM as well, and the radio doesn't come as standard with FM unless you fit the option board. But it does come with standard with LSB, upper sideband, CW, CW narrow and AM. So that's what we're going to be testing today. So we'll key up the transceiver, okay, and just let the test set tune up. And there we are, we've got the Rohde Schwarz radio test set there. We'll just zoom in a bit so we can see the screen a bit better. Okay, so right, so we're doing unmodulated about 27 watts. We're going to modulate 5, 1, 2, 3, 4, 5, got to about 134 watts. You can just see the RF power reading there, 4, 5, so you can see the RF power's quite good, and you can also hear the modulation coming back out the radio test set as well. I've seen the envelope on the oscilloscope. So that's at 7.2 megahertz AM. So we'll test the receiver now in AM next, I think. So we'll move on to doing receiver testing. Okay, so we set a test up now on the RX test now at 7.2 megahertz. We're injecting an RF level of just over half a microvolt, 0.545 microvolts. We're modulating this is AM at 60% mod at 1 kilohertz tone. So we'll turn the volume up now on the radio. We can hear a tone there. If I just increase the RF level, nothing wrong with that. So we'll put it to about 0.3 of a microvolt, and then what I'll do is we'll turn the preamp on. You can hear there the preamp's coming on. Set the attenuator so it totally gets rid of it, and that's back to normal. Okay. Now I'll increase the RF signal level on the radio test set so we can see the signal meter going up. As you can see there, no problem. So that's AM receive on 7.2 megahertz. So we can try other bands as well. Obviously we can try 10.136 megahertz, set RF to, that's 10.136 megahertz. Nothing wrong with that. What's the next one? 14.423. Nothing wrong with that. 18.103. So we can keep doing it right up to, I'll say, 27.974. Let's try that. Again, nothing wrong with that. So all the bands are good. 3.5373, 3.53 73 megahertz. Is that right? 53. Oh, 573. Is that when you type in the right frequency, doesn't it? So again, 3.573 megahertz, 1.806 megahertz. Again, no problem. So, receiver, no problem. We'll do a SSB test next on transmit as well as receive. Okay, there, just to show the band spread as well down to the lower regions of the amateur spectrum at 1.8 megahertz. We've just got the test set up for that as well, and we'll be able to see the performance, the power performance on AM at 1.8 megs. We'll do this test before we go into SSB, just to prove that the bandwidth of the RF power amplifier is up to scratch, even down at 1.86 megahertz. So here we go. Testing, 1, 2, 3, 4, 5. As you can see, they got up to 134 watts. 4, 5. 1, 2, 3, 4, 5. So no problem there. Can hear the audio coming back as well on AM. No problem. So just shows you, doesn't it? You can stick out some power even down at 1.8 megahertz. Okay, now we're on to transmitter testing on SSB. So we'll select mode, lower sideband. We've got the radio test set now set up to LSB mode, which is just here. You can zoom in, and then you should be able to see what's going on. Now what we'll do, I've selected the power hold measurement. So because it's SSB and the modulation and RF amplitude changes very quickly, I've set the test set to read peak envelope power, I've set the time to auto and the power maximum to hold power. So whatever maximum output power this radio gives when I modulate it will be displayed in the power meter. So then we're not trying to read the average, etc. So here we go. Right, keyed up the mic. I can hear myself coming back on the D mod. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1, 1, 2. 107.7 watts. So that's pretty good. Very pleased with that. So that's at 1.806 megahertz. So we'll move right up now to the top of the band and try it there. Okay, so I've got the radio now set to 27.974 megahertz just to demonstrate the top end of the band. I'm just going to key the microphone up. So here we go. 5, 5, 5, 5, 121.6 watts. That's not bad. So it's on LSB mode there, so not doing bad there for transmit. Okay, so we set up SSB RX receiver test on LSB. I'm receiving a 1 kHz tone from the radio test set. And we're only putting in about half a microvolt into the receiver as well. Nothing wrong with that. And you can squelch it out as well. Now, I'll change the frequency. It's on 10.136. Again, working fine there. 14.4231. tune it in using the clarifier. I can change to upper sideband as well, just mode USB, there we go. So I can tune that in as well. That's CW, that's LSB. Go back to LSB. Right, just move frequencies again up to 18.103 megahertz. No problem there. 21.279. That's working fine. 24.9003. Select LSB. That's okay. 27.974 megahertz. Again, no problem. If I select upper sideband and then upper sideband on here. So as you can see on upper sideband, lower sideband testing throughout the frequency range, we're not having any problems at all on the RX SSB side. So that proves that it's a good receiver. Okay, so I've got the case off now. We'll just have a look inside now that we've got all the screws off. So I'll just remove this aluminium can. Just make sure it's not been modified in any way or tampered with. Any issues. So we can see the antenna filter assembly here, and the bandpass filters, and then we've got the RF amp there, the two power transistors here, the main outputs and the output transformer, ultimately the input transformer for the two, and then we've got the drivers, transistors here, and the pre-driver down there, and the RF drive here. So all looks good, no burnouts or any issues there. Can't see anything around it. All looks good. Turn it over. Have a look here. Again, no sign of any modifications or anything like that. Nothing being tampered with. All looks good. Looks the day it was manufactured. So no burnouts or components added, anything like that. So good to go. I think we'll be able to put it back together. Everything looks as it should. So yeah, I think it's just a case now. Put it back together and put the anti-tamper labels on the case that the guy who gave me them wanted me to do. Okay, so just put an external aerial. Just have a listen round, see what's on.
Okay, schöne Grüße nach Ratzeburg, also Holstein, One X-ray contest. CQ contest, Oscar Tango, 1 X-ray, Ocean Tango, 1 X-ray contest. CQ contest, Oscar Tango, 1 X-ray.
Oscar Charlie. Thank you for 59 and 520. 59 and Quebec 07.
So machen wir das. Okay, dann hau rein und guck mal was. Ja, ich wünsche dir auf jeden Fall viel Erfolg und schönes Wochenende. Große Freude noch, ICOM707. Hast du das CQ contest, Hotel Alpha 2, Kilo Mike Radio contest. CQ contest, thank you. Good morning. Your 49 uniform 14. 197. Thank you. 73 and good luck. And Delta Radio 6 Tango contest. Delta Lima 1 Echo Bravo November. Schönen guten Morgen. Danke. 59 Uniform 14 United 14.
Shannon FIR UIR embedded thunderstorm observed within 5100 north 01120 west 5210 north 01120 west 5210 north 01025 west 5100 north 01000
RTQ Yankee 4 Mexico 59. Oscar Mike 2 Victor Lima in New York QSO Party. New York QSO Party. Ocean Mexico 2 Victor Lima. Oscar Mary 2 Victor London New York QSO Party. QSO Party. Ocean Mexico 2 Victor Lima QRZ. QCQ New York QSO Party. Ocean Mexico 2 Victor Lima. Oscar Mexico 2 Victor London New York QSO Party. QRZ. QCQ New York QSO Party. Oscar Mexico 2 Victor London. Ocean Mike 2 Victor London QRZ. Map 2. Echo 59 Delta X-ray. Again your county. Roger. Thanks a lot. Good luck. Oscar Mike 2 Victor London New York QSO Party. The execute New York QSO Party. Ocean Mary 2 Victor London. Victor London New York QSO Party.
This frequency is in use. Frequency is in use. Kilo Bravo 4 Charlie 4. Please repeat for info.
Charlie Romeo 3 Zulu, seeking contact. Charlie Romeo 3 Zulu, Charlie Romeo 3 Zulu, seeking contact. Charlie Romeo 3 Zulu.